Hello, I'm Dr. Laura Tolliver, representing Vadum. Today I'm going to be discussing Vadum's efforts on the electronic warfare advanced characterization engine to provide characterization-based electronic protection. The developments described during this tech talk were made during Phase 1 and Phase 2 cyber efforts in collaboration with the U.S. Navy. Vadum has four main technical focuses. They include advanced solutions for electronic warfare, sensor data exploitation, machine learning, and counter-explosive devices. Vadum has had multiple successful transitions to programs of record, including DARPA transitions and transitions to the U.S. Army. Vadum has an engineering staff of over 60 people, most of whom have master's and doctorate degrees. Vadum has a top secret facility clearance with secret computer processing facilities, along with electronic and mechanical prototyping capabilities. The maritime ISR missions are critical to find, track, classify, and target adversary vessels. Adversaries have access to increasingly more complex adaptive radio frequency jamming capabilities that could be detrimental to the success of these missions. The Navy desires to improve intelligence, search, and reconnaissance radar electronic protection capabilities against adaptive jammers. Vadum's algorithms perform capability-based jammer characterization and suggest electronic protection techniques known to be effective against the identified jamming type. Vadum's algorithms assess the effectiveness of the selected electronic protection technique and remember the effective technique to provide better matches in the future. Vadum's cognitive electronic protection architecture is deployable on a range of maritime surveillance platforms. Adversarial jammers continue to increase in capability and complexity. In order to combat these advancements, electronic protection techniques must also increase in capability. To accomplish this, cognitive systems capable of robustly employing effective electronic protection against agile jammers must be developed. The Vadum cognitive electronic protection inference architecture can be deployed not only on maritime surveillance radars for use by the Navy, but also on airborne RF ISR systems across the DoD and any other radar systems that are subject to advanced RF jamming. Vadum's solution to the problem is EW-ACE, the Electronic Warfare Advanced Characterization Engine. EW-ACE receives inputs from the radar in addition to some metadata if the radar is currently being jammed. Detection clustering is performed on the received inputs and is transmitted along with the metadata to the characterization engine. This is where features that are used for characterization are calculated, and then a capability assessment is performed. The assessment is inferred based on observed jammer behavior and gets sent to the jammer behavior object, or JBO. Based on the information in the JBO, an appropriate electronic protection technique is recommended. After the electronic protection technique is employed, the JBO stores how successful the technique was in avoiding the jammer to improve future electronic protection suggestions. The Phase 2 period of performance started in September of 2021 and will end in September of 2023. Vadum approached the problem with a three-stage capability development approach, where each capability has an increased complexity following a crawl, walk, run approach. At a high level, the problem was divided into four main tasks. The first task is the development of the jamming testbed, which is currently 90% complete. The implementation of the first capability had basic electronic protection technique selection, characterization, and jammer capability, and was demonstrated in a closed-loop scenario. This was completed in September of 2022. The second capability stage increases the complexity of the jammer, along with improving the characterization and electronic protection technique selection to provide protection against the more complex jammer. This stage will be complete in March of 2023. The final capability state has another increase in the jammer capabilities and improves the characterization and electronic protection technique selection accordingly. The final stage will be complete in September of 2023. Vadum's EW-ACE approach is currently the only known approach to this problem, and there are no other competitors known at this time. There are two main features to the unique EW-ACE approach. The first unique feature is the characterization approach. Vadum's approach studies the radar jammer in situ and matches EP techniques to the capabilities of the jammers. The benefit of this technical approach is that it is extensible and responsive to new threats. The second key feature of Vadum's EW-ACE technical approach is the persistent data storage. This allows information learned in situ to be stored for use later in a mission. The information can also be transmitted to other platforms or to the intelligence community to be used in other missions. Vadum's unique data storage technical approach enables cognitive behavior, where the effectiveness of electronic protection techniques continues to be updated, and new suggestions continue to improve as the radar system faces new threats. Vadum's technical approaches also provide a way for the learned capabilities to be propagated through the fleet and vetted by intelligence personnel. Continuous improvement and complexity increase through the Phase 2 development effort allows for consistent delivery of the capabilities. The Vadum team can incorporate any sponsor or warfighter feedback to develop improvements during the development process. The initial transition of the EW-ACE capability will begin through integration with industry hardware and software systems. Other transition activities will identify potential government and industry partners for technology transition to programs of record. The primary transition path for Vadum's EW-ACE cognitive electronic protection architecture is to integrate the architecture with the electronic protection component of a developmental ISR platform. A potential secondary transition path includes adding the Vadum cognitive electronic protection engine to new ISR platforms. Vadum continually partners with industry collaborators and program offices to evaluate and transition its capabilities. Vadum also plans to evaluate the cognitive electronic protection inference architecture in modeling and simulation and live virtual constructive environments. Vadum is open to discussing our efforts on this SIBR effort as well as our other technologies. Please don't hesitate to reach out to myself or Ms. Kara Van Nice for further questions or discussion. We're looking forward to hearing from you.